All right, to graph this piecewise function, there's a couple things we need to know. We need to understand what are all of our functions that we're going to graph. So first, let's kind of get our XY axis that we're going to graph everything on. And you can see we have an absolute value graph. So let's remember the parent graph there. So absolute value of X, that's going to be that V-shaped graph. We have a linear equation that's Y is equal to 1. And if you remember, Y equals 1, it's just going to be a nice horizontal line. And then we have a quadratic. Okay, so that's going to be the X squared. And then we have our U-shaped graph. Okay, so we know the parent graphs of at least the equations that we're going to be dealing with. And then we have our domain restrictions. Now, what I like to do when I have multiple domain restrictions that are not on the y-axis, I'm just going to draw a little dashed lines to separate my graph. So I have -2. I'm going to draw a nice little horizontal dashed line, and I have +1. Okay, the reason why I'm doing that is for each of these sections, one of these functions is going to be true. So for this section right here, this is for x values that are less than -2. We have the equation y equals 2 times absolute value of x plus 2. So that's going to be my V-shaped graph. And we need to understand, well, what are these transformations doing? So obviously the x plus 2 is shifting the graph 2 units to the left. And then we have a vertical stretch of 2. So rather than going up 1 over 1, we're now going to, or sorry, over 1 up 1, we're now going to go over 1 up 2. So you can see this graph is going to be vertically stretched a little bit more. So I'm going to take this graph, I'm going to go over to -2. Now again, this is x is less than -2, so therefore that's going to be an open circle. I'm going to go over 1, and then it's going to be up 2. Now again, I can only graph everything to the left. Even though this would be a V-shaped graph looking like this, I can only graph to the left of this domain restriction, which is x is less than -2. So the graph is going to look something like that. Now in this case, I have y is equal to 1. And if you remember, like y equals mx plus b, if you don't have a mx, then you know that your slope is going to be 0. So this is just going to be a horizontal line, right? But you're not going to graph it for all x. You can only graph it between -2 and 1. And again, x is less than or equal to a -2, and x is less than or equal to 1. So therefore, that's going to be a solid circle to a solid circle. And then last but not least, we have our quadratic, which you can see, again, is being shifted 1 unit to the right, so that's good. But then we have a negative in front, so rather than vertically stretching, like we did for absolute value, it's now going to be reflected about the x-axis, so it's going to look down. But again, we can only graph this to the right of our domain restriction, which x is greater than 1, so it's going to be a nice open circle, and looking down like that. Now again, I don't want my teacher to be confused thinking I was drawing asymptotes, so I'm going to erase those, but now you guys can see what this piecewise function looks like.